Hello learners, I take this time to invite you to this lesson. Computer hardware is our topic. The subject is ICT. We are looking at ICT, and the items that we are going to look at, the hardware. Our topic is the hardware. So we are going to look at the hardware as a definition, computer configuration. We're also going to look at computer peripherals, then central processing unit. We're going to look at computer functional organization chart, control unit, arithmetic and logical unit, and thereafter we are going to look at the main memory. So look at those, the list of the items clearly, and note them down. Ensure that you will follow as you follow the explanation. The person taking you through is Mr. Kichui, the experienced computer expert, a teacher, and at the same time an author of several computer books. This tutorial is delivered to you under the PECO, or Professor Education Consultancy, and the school is known as PECO Virtual School. PECO Virtual School. So you are invited to this lesson, but as you are going to study, take opportunity and visit any bookshop in Uganda and find these books. One is the Direct Points, the Bulldozer. They normally call this book the Bulldozer. It is a book of practical. It has a lot of instructions and even a DVD of video tutorials. If you will wish to either follow the book or the DVD, or you can do both. The other is Direct Points, Elementary Programming and Web Design. The programming is in C. Web design, you can do it with the HTML. And if especially your dream is to become a computer scientist, please look for this book. Look for this book and do the needful. There are video tutorials and learning programming. You become an expert, so that later on when you join university, you don't hire people to do for you programming projects as what the other students do, and eventually they become unemployable. No one can employ them because they could not be able to program. But if you use this book, you will have a good foundation for programming. Now let's proceed. We now look at computer hardware. Computer hardware. Now, what is hardware? We are not looking at any hardware, because the hardware, even woody, that is the hardware. When you come to car, has devices which are hardware, but here we are looking at computer hardware. So we are only going to talk about to look at computer related hardware devices. So hardware describes the physical components of a computer that can be touched and seen. Okay, there are some components which are in software form. We can never see them. That's why we insist on hardware as physical parts which we can touch and see, and that one describe hardware. But there are other form of instructions which work together with the hardware, which we can't see with our blank eyes. They are not seeable, you can't see. So examples can be a disk or disks, as you can see. This one you can see, they are physical, they are hardware components, you can see. Also disk drive, you can be able to see a disk drive, you can explain it, you can look at its physical appearance, you can touch it, and you can even see its mechanical parts as it works. That is a piece of hardware. You can also see the screen, that is a hardware item. You can see the printer. All that describe those physical items, hardware. So they are computer hardware or hardware related devices used in computer. But there are many others, not only these mentioned here. So hardware are computer equipment used to perform input, processing, and output activities. That means all these hardwares are grouped according to the nature of activities they are used to perform. Some hardware are used for collecting data to the computer or inserting, entering instructions, inputting. We are going to look at the input, what are input hardware. We are going to look at them clearly as we follow the lesson. But there are some which are used for processing. Find it is a hardware component, but its task is used for processing. To process is to work upon the data that has been input so that you can produce results. Then others used for outputting data. How do you now get the feedback? After data has been entered, then processed, you need the other devices specially for viewing or getting back the feedback. Okay, so let us look at computer configuration. Mark these terms clearly. Computer configuration. When we look at configuration, we look at the physical appearance of something, the way it is configured. When you look at the configuration of a trailer, semi-trailer, a bus, how you look at the components put together. So even a computer is configured because it has separate parts. Okay, now we say the computer configuration or system. When you say system, it means that it is something that has parts which are working together. So when we talk of computer system or computer configuration, it is because a computer has parts. It has several parts. So we say the computer configuration describes the way the physical elements of a computer and its peripherals are interconnected. Computer, so mark down the computer and its peripherals. We are going to look at what are peripherals and what are computer, because we need to how do you separate a computer itself and the other peripherals. Okay, so look, when you look at this, here we have a computer or the system unit as we are going to look at, but there are many attached components, several attached components. Have scanner, modem, mouse, and many others. So when you have all these one connected together, connected, you can see there are cables running. All of them are running to be connected there. So when they are all put together, we call it computer system or computer configuration. It has been configured. When you remove them, you are disconfiguring. When you remove them, because these one are removable. You can remove the scanner, you can take it away. So if they are all separate, it can't make a configuration. But when you attach several of them according to your needs, if you remove one, it does not lose the sense of configuration. If you can still work, okay, because you may not need a scanner, you may not need a modem, you may not need, but you may need others. So all these attachments describe configuration you have put together. It's like you, the human being, with your other limbs, other organs. You have the hands, you are configured with your body, the chest, the hands, the head, the legs, are there working to make your whole body. Okay, so let's look at computer peripherals. Now, computer peripherals, we need also to understand what does peripheral mean. Okay, computer peripherals are all devices that are being attached or connected to the computer CPU. Example, the keyboard, monitor, screen, printer, diskette, scanner, mouse. Like this one is a peripheral, this one is a screen. Okay, this is just a keyboard. This is just a drive. Okay, a printer, have a mouse. These are peripherals. Now, sometimes this term peripheral is an English word which means something that you can do without. It is a borrowed term. Can mean something that it is not very important, something that can, or which is not very seriously needed. Now, since the CPU or the computer is at times regarded as the most important component, it is the one that really deals in processing. So when we talk of computer peripherals, we describe all these devices that do not really work with the CPU during the processing. We don't say, at this point, we can't say, if we are to use English, all these devices are important. But this word is borrowed. Peripherals, when we describe that something that is not very important, in a computer, we don't mean something that is not important, but we mean devices that are not in the central processing unit. They are not really working in that processing. They are out of processing. Their work is simply to enter information or data for processing or receiving. So as when the CPU, the way it operates, because the CPU's mechanism is made to perform at a very high speed and to interact with several other components within it. But when such activities are taking place, these attachments have no part to play, and so we call these devices peripherals or computer peripherals. They are just peripherals, but we always need the screen to view, but it doesn't make it part of in the same part of the CPU. No, that importance of the screen reduces. Even if you switch off the screen, computer will process normally. It will work. So with this is a system unit we are going to look at. This is where the CPU is housed inside. Now all these peripherals will be attached here. They will be attached here, these computer peripherals. So in examination, you may be told to list computer peripherals. So you should be able to understand, to give examples, to define what is a computer peripheral, or define computer peripherals, give examples. So don't make a mistake of saying random access memory. That one is not a peripheral. But these devices that you see outside the system unit and they are attached, all these are computer peripherals. Now we have what we call central processing unit, or the processor. Central processing unit. Central processing unit. What is central processing unit? The central processing unit is the hardware within a computer system. A hardware. This is a hardware within a computer system which carries out the instructions of a computer program by performing the basic arithmetical, logical, and input-output operations of the system. Meaning that when data is entered into the computer, it's supposed to be worked upon. But which device is in charge to carry out these operations? That is CPU, or central processing unit. It is a device within, and it will, because when data is to be worked upon, the computer does not just work, or central processing unit does not just work. It works following the instructions, and these instructions are the ones at times we call them programs. So to work upon these instructions, that must be the CPU. These instructions details how that data should be processed, the data entered. So the CPU, if you are to open your machine, you can see it in that form, that hardware inside the computer, or you can see it in a different form. There are any variety of form, depending. Like here you can see the label, the CPU. Some of them may not label, but at times you have hard core, i5, what. But when we describe the CPU, we shall not do our best if we describe the physical appearance, but we describe it in form of roles. The role that it plays, not necessarily the physical appearance. The physical appearance, that one is not as much our concern as what is the role. We need to know the role, and also need to know that this piece of hardware exists and what do we need it for. So this is the hardware that where the work of processing is done. The work of processing is done. Hence the CPU can be described as the computer brain or heart that monitors all the computer operations. So think of your brain, the one that is helping you to sort out all the daily issue, to reason out. Think of your heart. So the CPU plays the same role in the computer system, in the entire computer system. It is highly dependable. If it is not there, then you have no computer at all. So I can say the CPU is the actual computer. If you have no CPU, you don't have a computer. You may lack a mouse, but not the CPU. The CPU is the everything when we talk of computer. We shall continue learning about the role of the CPU. So you may be asked to define central processing unit. At times they say write the CPU in full. So you should know that the central processing unit or CPU is the hardware within a computer system which carries out the instructions of a computer program by performing the basic arithmetical, logical, and input-output operations of the system. You just need to understand it that way. As we continue, we shall learn what are these arithmetical and logical operations. When we talk of input or output operations, it monitors data that is input and also monitors how data should be given out as a feedback. So all those operations are monitored by the CPU. Now, still we'll continue with our central processing unit, that the CPU is made up of the 5 main components. There are several others, but let's look at this key, and you may not hear carefully because you may still be asked to list the components of the central processing unit. So note down carefully. 1, we have control unit. So there is one piece of hardware known as control unit within the CPU. We also have arithmetic and logical unit. Arithmetic and logical unit. We shall understand what they do. Registers. We shall look at the registers. What are they? And buses. Not these buses you see, a bus, a minibus, no. But we shall look at what are the buses ahead of this topic. But we also have the main memory. So in your process of learning, when you are reading, don't hesitate to practice writing down, understanding, knowing what are the components found in the CPU. It is your task to know, to understand, to read. So before even you know what a control unit is, before you even know what is ALU or registers or buses, but understand and be able to list the components within the CPU. That is a step of learning. Learning is a process, you should know. You don't have to learn things at once. No. In the first place, ask yourself, do I know components? Can I list them? Can I mention components within the central processing unit? Then if you can, if you start doing it and you practice, you know that at least you have known that. Before even I'm able to define, it's like you know that you have a hand, but if you are told to find out the details of your hand, you may not have the proper scientific ability to do that, but you know that you have a hand. So also know what are the components found in central processing unit. Be able to list that so that if the examination at any one moment asks you to list, you don't miss such a simple question. Now we have what we call computer functional organization chart. We look at the different components and their relationships. Different components and their relationship. Now let us draw the chart. You see, let's assume that one is the processor or the CPU. The processor, which within it has the components. Now with there, we will see that we have a control unit, we have arithmetic and logical unit, we have main memory. Now, registers, buses are hiding within, and we shall talk about them. But according to your level, let's understand the structure of this part. It is easy to describe control unit, arithmetic and logical unit, main memory within the processor. Look carefully. The processor will interact with the input devices. You see there is input devices which will interact with the processor, but we also have the output devices will also interact with the processor, but they will interact how? There are others. We have backing storages. We are going to look at what are backing storages, or example hard disk. The input devices, we have an example of the keyboard. Output devices, we have an example of a printer or even a screen where we always see. Now, look at these major components where we have the input, but we have the CPU, we have the output, output devices. This one is the CPU with its components. This one is the input devices, for which example a keyboard. There can be many. Here is the backing storage. We shall look at what are the backing storages, but I will also explain it here. Now, look at these rows. See at those red lines. Those red lines are coming from control unit, pointing all the rest of the devices. They are dotted lines. Why? Why is it that control unit is showing lines which are coming from central control unit, moving it, goes, touches the output, it goes, and come and touch arithmetic, goes, touch main memory, comes and touch backing storage. Okay, even here comes and touch everywhere control unit. This is to show that control unit is in charge. It commands. It is the one in control. It is the one in control of all activities that are done in the system. So nothing can be done by any device connected or within the CPU without the notification of control unit. Control unit must be there to deliver commands, instructions, as we are going to see. So the dotted lines shows command, shows it is the one in charge of the kingdom or the empire of this computation. So you should be knowing that. Then other interaction, look at input devices. Always data will be entered. Anything to be done by the computer, request will come from outside the computer, because computer does not know what to do. Things human will collect data, they know what they want the machine to do. So it is the input device to be used to put, to force or to enter that data into the system. But when that data is entered, the first component, the first device that will receive that data is main memory, not the arithmetic and logical, not the control unit. No, the first device that will receive within the processor, within the CPU, it is the component known as main memory. And mark me clearly that this memory is known as main memory. There are other form of memories which can store. Main memory will store, but there are other form of memories. But the one which will receive any instruction from the keyboard, from the mouse, from any input device, it is main memory. Main memory. So after receiving, it will send a signal. This thing will happen very fast to the control unit, which is in charge. Why is it that control unit has to receive? Control unit. It is because the control unit is the one that makes interpretation of all what is requested. There is no any other device here that can understand, because these instructions that are coming from the outside world, from through the keyboard or the mouse, these kind of instructions are in human sensible form. But when they get to the computer, they are supposed to be in machine sensible form. So they require interpretation. They require interpretation. So the control unit will receive the instructions. When anything that has been entered, it has to be notified. And when it is so it will be fetching. It's like fetching whatever is entered, fetching, making interpretation so that the other devices can understand. So it will interpret and issue commands. It will interpret and issue commands immediately. So that's the reason there is an arrow pointing from main memory to control unit. That's the reason there is an arrow pointing from main memory to control unit. Why? Because when the instructions are entered to main memory, those instructions requires interpretation. But which device that is in charge of interpretation is the control unit, of which it is the very device, after making interpretation, it will issue commands to the appropriate device, because depending on what is to be done, this one must be aware so that it can command the necessary component to perform or to execute or to work on the instruction. After which, when the interpretation are done, the device which is in charge to work on, and it will be commanded by control unit still, is arithmetic and logical unit. So the whatever is to be done will be taken there to arithmetic and logical unit after it has been commanded. So so the action will come here to command the arithmetic and logical unit. That's why when immediately the data must come here for working upon. Maybe it was 8, maybe number 8 was entered and number 6, but they are supposed to be added, so they have to go there for arithmetic and logical unit for addition. Okay, so after addition, we expect the result back to main memory. So it means that the main memory here will keep items of data waiting to be processed, but temporarily. But even when the item of data have been taken here for processing, whatever the processing, the result will be brought back to the main memory, okay, before it is taken elsewhere. So after which we can get the output. Can you see the feedback? You see that input has some data has been entered, but before anything is done, interpretation has to take place. This is a channel that signals it alert the control unit for interpretation. Actually, it is the control unit which will be the first to fetch. Here shows that they will fetch those instructions, make the necessary interpretation, and with that, usually the arithmetic will be alert now the interpretation will have been made showing what are you supposed to do with that data, either add the data or divide one data to another or subtract one data item from another data item, and so on. Then the results are to be brought back to main memory. So can you see the memory will keep here several data items that are entered. Depending on the instructions, they go there for processing. Feedback comes down before it is communicated elsewhere. So, but usually we have other storages called backing storages, which can be a hard disk or a flash disk or external hard disk. These can be storages which can store a lot of data. Main memory, we shall look at it later, that it stores little data, and data stored there is stored there temporarily. The data item stored in main memory is temporal. If you switch off the power, nothing can remain in memory. So it is just a working memory. Main memory is just a working memory. It's not for storing information. That's why for storing data permanently, much as we have given the feedback, you the user, you see, but you may admire to store that data, okay, to any of the backing storage. Backing means to help, to provide extra, to put that information in other devices which can store at least that data in a permanent form, because main memory stores this data just temporarily. So it is just here to provide the working area, not to give the permanent storage of information. No. But you know, when data is in backing storage, like a hard disk, like a external hard disk, like a flash disk or a DVD, which can store information like in music or any other information, or even you may be watching this information from a DVD, or it is stored anywhere. It means that you are it is being retrieved back, it is being read back. Reading, when you are reading from a DVD, it means you are reading back, it has to be ready to back to memory. Okay, because when the computer is working, everything must be worked upon within the memory. So here you store permanently, but when you want to read that information or to access it, it has to come back to memory, so that the processor, when it is working, can always access the memory. We shall learn that later, that backing storage operates at a low speed, but memory works at a very high speed, so it can match its interaction with the control unit, arithmetic and logical unit very fast. But the backing storage devices are slow. We are going to look at that. So that's all about this. But let us look at the key, that when you see the arrow of this type, this arrow, it means data or instructions are flowing. Data or instruction are flowing, they are moving here and there. But when you look at that, arrow, what does it mean? The dotted arrow, it means command signal are flowing. Command signal. So the reddish dotted lines indicate commands. What are commands? Do this. Do that. Do, you command. The other arrow is just the data which is flowing. Now let's look at control unit again. We are describing the control unit, not by physical appearance but by role. We are defining it based on its role, not necessarily its physical appearance. It is a piece of hardware, yes, but we are interested to look at what is the role. So the control unit uses electrical signals to direct and supervise the entire computer system to carry out or execute stored program instructions. Understand the language used. When you say it uses electrical signals, it means that these signals that it uses to command are electrical. Then to direct and supervise the entire. When we say the entire, it means all. The term entire means all components that are within the computer system are being supervised by the control unit. So to carry out or execute, but this word execute is a very key term in computing. We use execute when we mean to work upon, but you work upon on something according to the instruction given. So when you follow the instruction anyway, if anyone gives you the instruction, those instructions are not yours. You are given instruction that do this, and you go and do according to what you are given, then it means you are executing. If someone sends you to go and arrest somebody, assume you are a policeman, you have no reason, you have no personal reason to go and arrest such a person. But what are you doing? You are executing order. So the term execute describes that state of doing things according to what you are told. That's why, because the computer does what it is told, we use the term execute, stored program instructions, and that is the definition. So we can also say that the control unit does not execute program instructions. The control unit, it does not. But what does it do? It directs. Itself doesn't do. It simply says do this. You can, if you are in class, a teacher can enter and tell you pick papers in the class. For him, he doesn't pick. He's telling you, then you start picking. You do it the way you are told. Tell you take the rubbish you are collecting or the litter, take to the bin. You are doing what you are told. Tell you copy notes. Or do this. For him, he's acting like a control unit. He's just controlling you, but he's not doing. So that's the same as control unit. It doesn't do. It is not defined to do anything. Rather, it is defined to direct other components to do, and it is given capacity to know which task can appropriately be done by which device. So it will not direct a device to do something that it cannot. For instance, control unit, it cannot tell the printer to calculate. No, it knows the printer won't be able to calculate, but it knows that the printer can print, can produce out the paper. It knows that the hard disk can store, so it will direct the hard disk to store a particular chunk of file, but it will not tell the screen to store. No. So it will give instruction according to the capacity described by a particular device, and that's the work of control unit. So the control unit does not execute program instructions. Rather, it directs other parts of the system to do so. The control unit must communicate with both the arithmetic and logical unit and memory. It must communicate because they are working together. They are within the CPU. Now, when you are reading, you must be always calm to follow line by line, so that you don't get lost in explanation. Like here, you should know the role of control unit very well, separate from those of arithmetic and logical unit and memory. Here we say memory, but we mean main memory, because that even hard disk is a memory, even flash disk is a memory. Anything that can store is a memory. But we are talking of main memory, which sometimes they simply call it memory, but we mean main memory. Sometimes some people just mention memory, but we mean main memory. Now, from there, this diagram, I just bring it back to further help you understand that here the control unit doesn't do anything. It is simply directs all other components on what to do. Okay. Now, there are several functions of control unit. Functions or roles. You can say functions or you can say roles. What is it used for? Uses of control unit. If you don't say functions, you can say roles. If you don't say roles, you can say uses. What is it used for? We have briefly explained it, the uses, but let us break small items down here. That the memory, the main memory, I mean the control unit, is used for retrieving and decoding. Retrieving and decoding program instructions from the main memory. As you could see, the arrow pointing to main memory, from main memory to control unit. When you go back to the diagram, see the arrow. When you go back to the diagram, see the arrow pointing from main memory to control unit. So that arrow pointing there is retrieving. What do we mean by retrieving? Retrieving is fetching. If you have a mango hidden in a bag or basket, a sack, you are trying to pick a mango inside, it means you are retrieving. You are retrieving. But this time, what is being retrieved? You are retrieving, you are picking something hidden in maybe a sack, or a basket, say a mango, a fruit, or anything. You are picking, you are retrieving. You are retrieving or fetching. So then after fetching or retrieving, it is decoding. And decoding. To decode, what does decoding mean? To decode is to interpret. To interpret. But this term is common in computing. So you should know how to use also computing terms. You may have other terms that you are used to, but this is the term used here, decoding. So decoding is to interpret or to make it understood. Now, this instruction that comes, I have told you that they are in human sensible form, because the users will simply type data. They will use the keyboard to type, but when that data is entered into the computer, it requires interpretation, so that it can be in those wire forms, in those machines form, to make it understood. So to decode is to make those instructions understandable by other devices, by other components. So even a printer cannot do anything. Even when you click somewhere print, it will still be, for you are going to click somewhere, but it will be the control unit to make that interpretation for the printer. It will make that interpretation and issue the command to the printer that you are supposed to do this. So retrieving and decoding program instructions from the main memory. It will retrieve from the main memory and make interpretation. Okay, and then after interpreting from the main memory, it will make the computer execute these instructions. It will make the computer execute these instructions. So the D component that's supposed to be to execute, it will clarify the function, the control unit will clarify. So it means that one point you should know that it is retrieving and decoding. You have known that retrieving is to fetch, to get something, and to decode is to interpret, to make something to be understandable by the others, which are those computer components. So retrieving and decoding computer instructions from the main memory, and to make the computer execute these instructions. Then number 2, coordinating and controlling various parts of the computer system like main memory, arithmetic and logical unit. ALU stands for arithmetic and logical unit, and peripheral devices. Peripheral devices are those devices that are being attached. Now they work together. All these components work together, so they need to be coordinated. Now who coordinates them is control unit. So control unit is a coordinator. It's a coordinator of these other components. That's why we say coordinating and controlling. You coordinate and control various parts of the computer system, like what? Like main memory, ALU, and peripheral devices. Because peripheral devices are many. We have printers, we have keyboards, we have mouse, and many others are being attached there. So they need the coordination of control unit. The other, controlling the transfer of data. Controlling the transfer, there is data movement within the CPU. Data movements. Data moves from one device to another. Data will move either for processing, then it come back as a result, then it will move. So all the movements of the data item has to be controlled, it has to be monitored. So we say controlling the transfer of data to. So data can move to. Data can also move from. That's why there is a comma. Okay, that data moves to or from, and it can also move within the main memory. So within the main memory there, data can be moving from other components to main memory, but the same data can be moving from the main memory to other components, or it can move within the main memory. So that movement of data is controlled by the control unit. Look, go back to the diagram and you will see that data can move to. I will show you in the diagram, but it can also move from, but it can also move within the main memory. Then, to control the sequence of operation, the sequence. The word sequence, I can compare it to a cube or a line of activities. I can give a simple example. At school, you line up for food. A student line up one after the other for food. So it means each student is to be served. Assume these cooks who are serving perform like a control. Someone is directing them, like a control unit. So you make a line. You are controlled to make a line, to make that sequence. So each student can act as a job to be worked upon. So you are controlled to make. Someone will be there controlling. Cooks are devices that work, but someone else can be a teacher who supervises so that the line is clear. So this person, your teacher on duty or prefect on duty, can be a controller to monitor the sequence. So to know which student comes first, who comes next. One of the supervisor may say, we want senior 1 first. Another may say, we want senior 6 first. That is monitoring of the sequence. And to ensure that you make up a line so that you may not all at once jump to the cooks. That way you'll be monitored. So in computing, there can be many jobs to process. Hundreds of jobs. So, or hundreds of instructions to work upon. Because of that, they need to be put in a queue or in a sequence so that the processor can operate one job after the other in a sequence, because the jobs will be competing for the processor. But if there are ways of monitoring to ensure that one job has to be worked upon first, then it comes to another job, that's the best thing, and that is the work. It is the control unit is the task to monitor that sequence. Then to store results in the CPU memory. So when data has been processed, there is the intermediate results that is produced. It is the main memory, it is the control unit to direct that result where it should be stored within the CPU. Now, this diagram again, I wanted to emphasize that the point of movement of data, where the control unit can control how data enters to. Can you see this arrow is pointing that the data can move to main memory. Or even here it can move to main memory. Can you see main memory receives a lot of movement in and out. Main memory has a lot of in and out. So it requires, see the arrows pointing to main memory and out of main memory. So you will find that the main memory is really a working area. So there is a lot of movement of data here. So the control unit has to be in charge to find out data is entering here. So it has monitor entering 2. When you look at the other point, enters 2. 2. Here it is from arithmetic to memory. From backing storage to memory. But it can move from memory to output devices. From memory to backing storage. From memory to arithmetic and logical unit. So, be keen. Next thing I want to talk about, you may be told to draw computer function organization. You need to be keen when you are drawing and showing the arrows. Show your arrows clearly. For instance, this arrow points to memory. You don't expect to have an arrow pointing from memory to input devices. Input devices does not receive anything from memory, but instead it will always receive. Main memory will have to receive from input. So the arrowing, also output, just receive, does not send anything, just receives. But here it can receive, it can also send. Here it can send, it can receive. So you should ensure that you study, practice drawing in this structure several times, read it through in order to understand what is going on. If you don't do that, you can't manage to understand. Watch the tutorial more than once. Draw the structure more than once, and that's how you will manage to understand. Then let's look at another item, the arithmetic and logical unit. In short, they say ALU. So even in examination, they may tell you to write ALU in full or CPU in full. So you should be, it is common, should be able. So the arithmetic logical unit, or ALU, is a circuit that executes all arithmetic and logical operations. So This piece of hardware, it is actually the one that really does the work of processing. It works together with the control unit, but this is the one being instructed. This is the really performer. It is the actual device that really performs these calculations. So the arithmetic and logical unit can perform 4 kinds of arithmetic operations or mathematical calculations, which can be addition, subtraction, multiplication, and division on arithmetic part. With the arithmetic, can be operation or can be mini addition, subtraction, multiplication, and division. So arithmetic and logical unit also performs logical operations. What are logical operations? A logical operation can be a comparison, to compare. Can you compare data items? So the unit can compare numbers. You can choose to compare 2 numbers to know whether is one number larger than the other. That is comparison. Are they equal? Is it less? That is comparison. The computer can then take action based on the result of comparison. When a system, a computer, tries to find out which child is position number 1 in examination, that action will be comparison. You compare the marks of one child, the average mark of one child and the other. You understand, who is supposed to be position number 1. Keep on comparing until the other comparison can be done by typing passwords. Maybe you want to access someone's computer, you enter your password. That password will be compared to the password which is inside there, and they will find out, no, you are not supposed to enter. If you don't enter the correct password, it will compare the password you enter and the one that is inside. When you try to get money from mobile money shop, you have to enter the password, else someone could simply withdraw. But when you enter the password of letters or characters or numbers and what, they are compared. That is act of comparison. Police can take fingerprint from a crime scene, and those fingerprints that are obtained from the crime scene, maybe someone has been murdered somewhere, or you break some shops somewhere, police can go there and take fingerprints from different items which they think the suspect touched, and then when they arrest suspects, they will compare the fingerprints obtained from the crime scene and those of the suspects. If they match, they will know, a thief is here. Otherwise, you may need to continue with the further investigation. So all these comparisons activities can be performed by this arithmetic and logical unit. Then let's look at the main memory. Main memory forms the working area of the computer. That is, all the data and instructions to be processed must be temporarily stored on the main memory, or in the main memory. Now, main memory is actually a very important component in the CPU, because that's where the computer works from. So it provides a working area. All the data to be processed must be temporarily stored in the main memory, and you will know that main memory stores that data just temporarily. It is a working area. It's like when you have a working room. You may be having many rooms, but when you want to work, you get to a particular room for working. You put all your things that you want to do in that room, So main memory, when the processor works, it really relies on main memory to get data from there. It is a working place. Let's continue studying main memory. That main memory can alternatively be called, so mark these names properly, because you may always hear people mentioning them. It is known as primary memory. Main memory is known as primary memory. It is a memory that is very important. So primary memory, or internal memory. Internal because it is within the processor. Because it is within the processor, is referred to as internal memory. So the other name can be internal memory. Even in some examination can tell you, list down other alternative names of the main memory. So we have primary memory, we have internal memory, because it is just within the processor. But also it is called random access memory, or RAM. I think the term RAM is very common. Someone, you go to a technician and tells, your RAM is spoiled, your RAM is what? So this main memory at times is referred to as random access memory. Random access memory. The term random is because its content can randomly be accessed. Randomly. There are some memory to access data there. You have to follow a particular sequence. You can't pick one data item before you have gone through the other. But data items that are in or within main memory can be collected at random, can be read there by the processor at random, making it read and write become very fast. Also, it is called immediate access memory. Immediate access memory. The word immediate, it means that the contents there can be accessed directly by the processor. Compared to other devices like a flash disk is a memory, but accessing there, processor cannot access there directly. A hard disk, a processor cannot access data there directly. But as of main memory, data there can immediately be accessed. That's why they call it immediate access memory. It is another common computing term. So, still on main memory, we can look at the roles, distinct roles of main memory, which you should be able to mention these roles. One, to hold data that is waiting to be processed. Data that is waiting to be processed by the processor or by the CPU can wait there. It's like a waiting room when you go to hospital. You are waiting to see the doctor. They can put you somewhere and you wait. They are not going to tell you stay outside the gate. No. You will enter and you sit somewhere. You make a line and you wait to see the doctor for treatment or for consultation, anything, but you wait. So you will be waiting. Also, to hold instructions or programs for processing the data, meaning that even in the instructions for processing that data that is waiting to be processed will also be held there. So number one is to hold data that is waiting to be processed, but also the instructions for processing that data will be held there, because data item, when it is just stored there and there are no instructions what to do with that data, the computer will be stuck. So instructions are needed such that when the data item now needs to be processed, you find out, is this data for adding with another item of data? Am I subtracting? Am I sorting? What is to be done? So the instructions for processing that item of data must be right there. Also, to hold the processed data results before they are communicated to any of the output devices. When a data item has been processed by, say, ALU, Arithmetic and Logical Unit, the intermediate results has to be brought back to main memory, and it will be held there before it is either taken for storage, permanent storage by the backing storages, or even being viewed by the user through the monitor screen, or to be printed out. So it will also be held there. So you must know these roles. You must be able to write them. Read it clearly, write down, practice, and the questions that will follow, you will be able to answer them carefully. Now let's look at main memory's functional areas. Functional areas. There are some portions which are in the main memory, and each portion has a particular function. For instance, the main memory consists of the following functional areas. So that one, there is a point called the input storage area within the main memory, and this portion is called the input storage area. What does it mean? That area, it will be the one that will hold the data that has been read from the input device. So when there is any information that is coming from input device, has an area to store that part, that item of data which is just coming from input device, and they call that part input storage area. They will not just put anything that enters main memory anywhere, no. Then there are another area will keep the program, which holds data from both system software and the applications software. That means this one is called the program storage area. So we have input storage area where it will store data temporarily, which has just come from the input device, which is there waiting to be processed. But another area will hold the program or the instructions to which is having the instructions of how to work on that data. Okay, so at first we have input storage area. Data will be stored there temporarily, waiting to be processed. But another area will be there for storing that program. Then working storage area. Another area now, it will be for working, which is used to hold the data being processed as well as the intermediate results of such processing. Then lastly, we have output storage area, which holds the finished results after processing until they are released to the user. They are always released to the user through the monitor screen or through the printer, or you can store somewhere permanently like a hard disk, or you can store to a flash disk, or burn it on a DVD. It is upon you, but as it is being held there, that area is going to be called the output storage area. So these points here regards main memory's functional areas which are demarcated there according to their function, that much as it is there is that whole unit main memory, but there are partitions of which each partition, one is meant for input storage area, another one for program storage area, working storage area, and the output storage area. That was the plan, and this plan holds water because you must get organized. Even when you have your case at school, you can demarcate that this area I can keep books, this area I can put my sugar, this area I can put clothes, but you have one container. So even main memory is organized that way. We can look at main memory setbacks, things that the main memory cannot really do much. Can say there are 3 reasons for not using main memory to store information. You can't store information in the main memory permanently. It is a temporary memory. So one reason, most types of memory only store data items while the computer is turned on. Data is destroyed when the machine is turned off. So this main memory, you can't rely and say I'm leaving my information there. Why? Because that memory is only active when power is on, when the computer is on. When you switch off the power, main memory will always remain empty. Anything that was stored there will vanish. So main memory's design is to hold the information when the power is on. So never rely and say you type information on your computer, you open a Word document, you start typing, and immediately you can type even 20 pages, but if you don't save or write if you don't say save, that information will look as if it is in the computer. You will have no content. But saving, it means you are writing that information somewhere, which may be a hard disk, a flash disk, and so on. But if you don't save, if you don't write that information to a permanent storage, then you will only see it on your screen, but when you switch off, you will have nothing. That's what we say, because that information was in the working area, was in the main memory, which we call it a working area. For you thought it is within the storage device, but no. So usually when you use a machine, when you type anything, you must save, you must write. To save is to write that information somewhere, like a hard disk, or take it to your flash disk, or burn it to a DVD. That will be saving. But if you just leave in the main memory and you say that if you don't save, it means that you have left that content on the main memory. You have not saved. It is there, you have been typing, you switch off the computer, next time when you say I'm not seeing my document. That is because it was in main memory. Also, main memory is limited. It stores very little information. Today's RAM can store some good amount of data, but you can't compare with that one of hard disk. Okay, so main memory is limited. It means that it can store little, therefore may not be enough room to hold the processed data. So it is only for working, but not to rely it to store a lot of information. Also, main memory is very expensive, given its storage size compared to hard disk. It is very expensive. It is little, it can store little, but when you ask the price, when you go there, you go and ask the price of RAM, you look at the amount it can store, then you compare with the price of hard disk, and you really compare. You will know that the main memory is very expensive. They will tell you this is a GB RAM, but it is around 60,000. Yet a hard disk may be storing close to 500 GB, but it may be around 150. So you will find that main memory is not that, given its technology of making it, it makes it to be very expensive, because it is made it to be very fast and working close to the processor. Then let's look at the main memory CPU, or input-output equipment. Generally, we can say main memory is the part of the computer that holds data and instruction for processing. It holds data, I'm always repeating this, it holds data and instruction for processing. Keep on understanding this. But there is a point here that although closely associated with the central processing unit, main memory or memory is separate from it. it is close. They are together. They are it is part of the processor, but it is slightly separate. When you look at the other architecture, they actually put it out of the processor, but it is slightly out. You will see in the diagram that main memory stores the program instructions or data for only as long as the program they pertain to is in operation. It can be stored there. Now, main memory just hold. It doesn't work. It doesn't work to perform. So, the most active devices is the control unit and the ALU. Now, look at this figure here, diagram showing that the main memory, look at main memory, CPU, input, output, and equipment. This is another alternative diagram compared to the one we looked at it at first. Now, this one shows that the really devices, again the processor here, we have arithmetic and logical unit and the program control unit. Okay, they put the control unit down here, showing that this one is a processor, but the main memory is much closer to the processor compared to input and output equipment. Okay, it is also part of the processor, but it's slightly separate. This is another diagram showing why is it taken as slightly separate. Is because of the speed issue. Sometimes you'll find a processor may need another intermediary component between main memory and the processor, because at times the processor can work at a very high speed, but we shall look at it after. This is just to bring you closer to another high level of learning, but mark the other diagram much more than this. But this one is, you will look at the other books, they will tell you that arithmetic and logical unity and the control unity are the key in the processor. Main memory is used for working. Main memory is used there for working, but of course here they combined the input output equipment to show that sometimes data will be entered and sometimes data will be received. Okay, out. So with that, let me leave you here for now. You'll keep repeating this video tutorial and ensure that you practice, you read, you copy those notes, you read, do exercises. If you can go to the bookshop and get the other book, in their book for notes, look for direct to points books for notes. Find your level and get the book, read. You will find that it can make you better student. Thank you very, very much.